All right, so we're picking up where we left off in the previous part of this same example. So I went ahead and I drew the free body diagram of the entire beam. So let's kind of go through this and make sure we know what we're looking at. On the far left right here, we have AX and AY, and then we have that moment of 91.2 kip feet, and it is going counterclockwise because we calculated a net negative there, okay? Now, here's B. Infinitesimally to the left of B, we had a moment of 155.1 kip feet, and it was positive, so it's going clockwise. And then infinitesimally to the right of B, we had 154.8 kip feet going counterclockwise, indicating that it's negative. We had a similar situation at C, and then at D, we had no moment there, as we shouldn't, because that's an end-spanned roller. Now, one thing I want to point out, the fact that we're a little far apart right here with these moments will cause a bit of a discrepancy, okay? The 76.6 and the 70.9 are not really close enough. I mean, we're about 10%, but 10%, you probably want to get it a little bit lower than 10% tolerance. Even though I did say 10% in the previous video, it'd probably be better to go for a little bit closer than 10%, just because I haven't drawn this moment diagram yet. I'm doing it for the first time with y'all in this example, but I have a feeling we're going to have a little bit of a closure problem when we get to that, okay? But let's go to town on this. What we want to do is use method of sections. Use method of sections to obtain externals. Now, what we're going to do is something very similar to what we did with slope deflection. Actually, it's pretty much the exact same thing we did with slope deflection. So we're going to use a free body diagram, FBD, of AB, and we're going from X is between 0 and 30 feet infinitesimally to the left. That's the domain that we're on, okay? Let me just draw that a little bit better. Infinitesimally to the left of 30 feet, so not including the 30 feet. So on that first free body diagram, I'm going to draw my little cut section right here, and I'm going to have, actually, can you tell what AX is for sure? Well, hopefully you can look at this entire free body diagram. You don't have anything in the X direction, so AX should be 0 here, and we have an AY right here, and then we have our moment that we calculated earlier, 91.2 kip feet. We got 30 kips here, and then we have this 155.1 kip feet, and then we're going to have, I'll go with a different color here. We're going to have a BY left right here, and then our normal force is still 0, okay? So we can, if you want, we can put a 0 right there to be proper. So here again, it's a method of sections operation. We're going to say sum of the moments about point B equals 0. We could just as easily sum moments about A. And we're going to say minus AY times, we should probably put our dimensions here, times 30 feet. And then we're going to have plus 91.2 kip feet. And then we're going to have plus 30 kips times 15 feet. And then we're going to have a minus 155.1 kip feet equals 0. So when we do a little bit of rearranging here, we should end up getting the following. Punch this through with me. 30 times 15 minus 155.1. So I get an AY of 12.87 kips reacting up, and then we're gonna sum forces in the y direction to equal 0, and we'll have 12.87 kips minus 30 kips plus by left equals 0, and we should get a by left as 17.13 kips, also reacting up. Okay, so we can kind of check off the values that we know. We got AX, of course, was 0. We don't know BY totally yet. We just know BY left at this point. Okay, so let's move on over. Let's look at a free body diagram of BC. So we're going to say FBD of BC. And we're doing something very similar to, again, it's actually at this point, it's like identical to what we did with slope deflection. So BC, we're going to have a BY right, and then, ooh, that's a weird label, BY right, and then here we're going to have a CY left, okay? And what about these, what else do we have here? These couple moments. We have a 154.8 coming in right here, 154.8 kip feet, and we have a 76.6 here, 76.6 kip feet here. And then we have 40 kips in the middle, 15 feet, 15 feet. And then, of course, the axial forces are 0, okay? So here we go. We're going to say sum of the moments. I'm going to say sum of the moments about C here equals 0. And when I do that, I've got 154.8 kip feet. And then I have minus BY right times 30 feet. I have plus 40 kips times 15 feet. And then I have minus 76.6 kip feet equals 0. So we get BY right as the following. So I get 22.6, or really 22.61 kips going up. And then we're going to sum forces in the y direction. And when we sum forces in the y direction, we should end up getting a CY left as 17.39 kips, also going up. Okay, so if what we could look at now, if you want, we can say free body diagram of B, and if we look at that roller at B, here is, let's go with the same color scheme I've been using. There's BY, and then here is BY right, and I'm sorry, BY left, and then this is BY right, which was 22.61 kips. Notice it's going down because we're looking at the free body diagram of B, so it's got to be same magnitude, opposite direction of this, and then a similar thing on the other side, 17.13 kips here. So BY should end up being, let's see what it is, 17.13 plus 22.61, 39.74 kips going up. So we can kind of check off BY here. And now moving on, we're going to look at a free body diagram of CD. FBD, CD. And when we do that, we have a cut here. It's an ugly member. There we go. Cut here. And we have our dy right here. And we have a cy. Did I label these? I labeled these all kinds of silly, didn't I? Not really. This is by infinitesimally to the left. Oh, what happened? This is by infinitesimally to the right, cy infinitesimally to the left. So cy, yeah, okay, I'm sorry. I thought my labeling was backwards, but it's not. Cy infinitesimally to the right of C. And then we have a 70.9 kip feet going counterclockwise. 70.9 kip feet here. Okay, so we're gonna say some of the moments about D equals 0. And we're gonna have 70.9 kip feet. This is 30 feet long, by the way. Minus cy right times 30 feet equals 0. And yep, we get cy right equals 70.9 divided by 30, a positive 2.36 kips. So it is going up here. And then when we sum forces in the y direction, we should get dy is 2.36 kips going down. And then if we looked at a free body diagram of C, we have a infinitesimal cy right there. And we would have cy right here, 2.36 kips. And then we would have a cy left. Yes, cy left was 17.39 kips. Okay, so cy should be equal to 19.75 kips going up. And just to also be proper, you know, your moments here should be in equilibrium as well. I didn't actually show them at the free body diagrams, but the moments at B and C should be in equilibrium, and we can see that by what's happening here. Okay, those should be in equilibrium. And remember, these are span moments that are shown on this free body diagram. So if we looked at an infinitesimal point here, then these moments are going like this. They're going the opposite of what we showed in the span. All right, so we're ready to draw. This has been a long example. By the way, I've done this nonstop. I've not taken a break in between these videos. I've been going at it the whole time. You can take a break when you're watching it, but I'm just trying to roll on through. So let's draw the shear diagram. We're gonna expand this out. This is x in feet, and here is the shear in kips. So the first thing we hit is AY. We got 12.87 kips going up. So 12.87. We had a whole lot of nothing for 15 feet. And then if you do 12.87 minus 30 kips, you get down to negative 17.13, and then a whole lot of nothing for another 15 feet, and then you hit BY. So we got a BY of 39.74 kips. So that's gonna add 39.74 kips. That's gonna shoot us up to a positive. That's going to shoot us up to a positive 22.61. Okay, let me see if I can move this down just a little bit to give us a little more room. There we go. Okay, and then what happens? Well, we got a whole lot of nothing for 15 feet. Whole lot of nothing. And then we hit the 40 kips, so we would say minus 40, and that's going to shoot us down to 17.39, right? So that's about right here, 17.39. And then we got a whole lot of nothing for 15 feet. And then we hit CY. So CY pushes us up an amount of 19.75. So that brings us just barely up here to 2.36. And it looks like I need to extend my axis just a bit. And then we got a whole lot of nothing for 30 feet. Whole lot of nothing. And then we hit DY, which pushes us down to 0. So this is our shear diagram. Nice looking shear diagram, if I say so myself. This is 15 feet. This right here is 30 feet. This right here is 45 feet. Yep. And then this right here is 60 feet. And this right here is the 90-foot mark. Okay, now we're ready for the moment diagram. So the moment diagram, remember you have a non-zero moment at A. Kip feet, here we go. And we're gonna make this axis long. Ooh, that looks so ugly. I'm so sorry. It's actually quite hard to draw a straight line on this. Okay, so we have a moment at A, which was 91.2 kip feet going counterclockwise. So counterclockwise couple moment causes a jump downward in the moment diagram. So that was, what was it again? 91.2. Okay, 91.2 kip feet. So that would be a negative. Then we hit, so we're saying negative 91.2, and we're going to say plus 12.87 times 15 feet. So that actually jumps us way up to 101.9, okay? Then we hit this negative area, so I'm going to say minus 17.13 times 15. So that's going to push me down, way down to negative 155.1. Okay, that's going to be about way down here. And that makes sense, right? That's about, if you look at it, that's about the couple moment that we calculated using moment distribution at point B, okay? So that makes sense to me. And then we're going to say plus 22.61 times 15. So that's going to shoot me way up to 184.05. That's going to be like way up here. 184. Point 1. okay? And then we hit this negative area, so we say minus, this negative area right here, minus 17.39 times 15. So that brings me to a negative 76.8. So that's going to be about right here, negative 76.8. All of these are linear segments. So we have a constant shear diagram. And then we're going to say plus 2.36 times 30 feet. And so here's what happens. It actually takes us, it's supposed to take us to 0, but I have a 6 kip foot discrepancy. Okay, 6 kip foot discrepancy, which that comes from the rounding off that we did during moment distribution, and that also comes from the fact that we could have done a few more iterations to get a better closure and a higher tolerance level when we were doing moment distribution. So you want to try to avoid these discrepancies the best you can. So really what we should have done was, in the first part of the video, we should have done moment distribution maybe one or two more iterations. In fact, why don't we go back and do that? Just joking. Just be careful with that moving forward, okay? Thanks for hanging in there with me through this very long 2-part video. Make sure you watch the whole thing, okay? In fact, if you didn't watch the whole thing, then you wouldn't know that I'm telling you right now to watch the whole thing. So I guess that's a moot point. All right, have a good night.